Okay, I think we can start. Thanks for joining. My name is Didier. I'm the technical lead for the HP developer community, and I'm really happy today we have to have Kevin with us from the Determined AI team within HP now to talk about this interesting title, which includes us all: large language model fine-tuning for mere mortals. Sorry. Before I hand over to Kevin, let me just talk to you a few minutes about the HP developer community. You might be familiar with meetups because you are here, so thanks again. We keep track of our calendar of events on our meetup page. I know Denis, my colleague, will put some links in the Q&A for you to cut and paste if you're interested. So this is a monthly series that we started 2 years ago. We try to go in depth on certain technology. We cover open source, dev, and more. We have a topic for September. That's the good news. On September 25th, sorry, we'll be covering a talk. We'll have a talk on Sustainability Insight Center, talking about the key features and the API capabilities. So you can already sign up for this. I know Denis will paste the link in the Q&A as well. We also have another type of monthly talk, which we started 3 years ago. Again, monthly. This is more like thought leadership, and it's trying to be vendor and product agnostic. We have a session planned in September as well. It's actually before the meetup. It's on September 18th. It's a session that was supposed to happen in July, but we had to postpone for with an issue with the speaker. So this is now going to happen, and it's about natural language processing. So make sure if you're interested that you attend this one as well. So this is for the webinars, but as part of the community, we try to also provide additional ways for you to skill up. And actually, we have a dedicated page called Skill Up on our website. And one of these topics is workshops on demand. If you have not ever tried that, take a look. The URL is on the page here, and I think Denis will also paste it in the Q&A. There is a catalog of about 30 workshops. These are using, we are using Jupyter notebooks, and we provide 24/7 access, and it's free. So anyone can get there, and there's a lot of reference in the catalog, which are open source stuff, you know, Docker 101, Kubernetes 101, what's a REST API, that kind of thing. And we also have HPE product workshops on demand. So give it a try and let us know if you have feedback, what worked, what didn't work, and what is missing from the catalog. Because this is a community, we need you to contribute and amplify. So if you are joining those talks and you think they're interesting, please make sure you invite colleagues and others to join the talks. Customers, if you are with HPE, we'll be happy to have more customers with us. We have a monthly newsletter to keep track of this type of meetups, but also the blogs that we release on our blog section on the website. So you can subscribe to the monthly newsletter. We also have if you want to engage and ask questions, we have a Slack workspace, a dedicated and external Slack workspace that you can sign up to. We have a channel for almost all our technologies so that you can engage in a discussion or ask a question. You can also follow us on X, Twitter. We have a handle for that. And if you're an SME, we are interested to talk to you for maybe authoring a blog. And we have a pretty simple system using Markdown and a GitHub account to contribute and create a blog. So it's quite quick, and within a week, you can have a blog up and running on the site. You can also reach out to us if you're an SME to deliver a meetup, such as the one Kevin is about to deliver, or even participate to some events when we have the Hack Chat, for example. Finally, you can also talk to us if you think that in the workshop on demand, there's a gap and you can help. We have a framework, but of course, we cannot build all the content we'd like to. We're not such a big team. So reach out to us. These are all the links. You might be interested to join the community in various ways. The QR code also provide those page with all these links. So feel free to use. Denis has also pasted the things in the Q&A. Please use the Q&A for your questions and use the chat as well for discussions. And we'll try to answer all your questions. This said, I'd like to get started and hand over to Kevin for the rest of the content.
All right, so I'm Kevin Musgrave. I'm a ML developer advocate at HPE, and I'm going to be talking about fine-tuning LLMs and some of the very practical challenges. So not necessarily theoretical things, but just things that you would come up against as like an ML engineer or an engineer who's not familiar with machine learning but still wants to use LLMs and fine-tune them to a specific application. And then I'll talk about, I'll show you an HP software that can simplify a lot of these things, make it really easy to use. So just to give some context, I think everyone agrees that LLMs are very useful. They're being used for as coding assistants. They can write blogs for people. They can summarize things. They can give yes/no answers. If you can ask a question like is this which piece of writing is clearer. There's a lot of use cases in many different industries. It really goes across everywhere. So maybe the finance industry, healthcare, software engineering, and so on. And so the big question is, how can you actually use these LLMs? How can you take advantage of this technology for a specific use case and without spending lots of money and having the ability to customize the LLM for what you're doing? Because of course, we can use something like ChatGPT or Claude, but that's not necessarily the most cost-effective approach. So to break this down a bit, basically, there's different ways to use LLMs. And here I've broken it down into location and customization. So location means where is the model and the data. So, you can have self-hosted model and data, meaning everything resides on your own servers. You aren't sending your data or, you're not making API requests to some external server. And a third-party service is something like make an API call to OpenAI or Anthropic. And so effectively, you don't own the model, and also you're transmitting your data to them. And so that, there's trade-offs there. Obviously, third-party service is very convenient. Self-hosted, you can keep things private. And in terms of customization, this is basically, how do you get the LLM to do what you want? The most basic form is prompting, right? You can just tell the model what you want it to do. So you take a model off the shelf, don't change any of its weights, and you just say, you can ask it to answer questions a certain way or give it some examples of what you want it to do, and hopefully it responds, in a similar format. And so retrieval augmented generation is another one that's similar in the sense that it doesn't modify the model at all, right? All you do is you go out and retrieve data. Given some query, you try to retrieve data from a database that hopefully contains the answer to that query. And then you just put that into the prompt, and now the LLM can hopefully answer based on having that data and the query. Now the LLM can hopefully give a correct answer. And this is something that's commonly used to avoid hallucinations. If you want an LLM to answer very specific things about, for example, your products or something that's not generally available online that the LLM wouldn't have been trained on, then this is a common approach to solve that problem. And finally, there's fine tuning. So this is the one form of customization here that actually changes the model itself. So this means you're going to be training on some data set you have to modify the way the LLM actually responds to queries. And So this is the way to get like the most customization out of these three choices here. And so I'm going to talk specifically about self-hosted models and data and fine-tuning those models. And so why are we interested in self-hosting and fine-tuning? Well, with self-hosting, you keep your model and data. You don't need to be worried about what other companies are doing with your data or what they're doing with your model or your API requests or anything. Even if they claim to, be totally trustworthy, you don't have to trust them on that. You can have everything in-house. And furthermore, you can have all of your you can have in-house optimizations. You can have more customization on your own with your own models and data. And in terms of fine tuning, there's a lot of cases where you can get you can use GPT or Claude, and they're very powerful models. But for a lot of use cases, they're overkill. So you're using a very large model, a very expensive model to do something that you could actually do with a smaller, cheaper model that's been fine-tuned. So, the benefit of fine-tuning basically is that you can get much better performance, and that means you can use a smaller, cheaper model. And that also means a faster model, so you can get faster responses. So there's this advantage, we have self-hosted models and fine-tuning them. But the issue is that there's a lot of sort of tedious little details to take care of. Like even if you're not going in there and writing every line of training code, there's a lot of things to configure. And even if you're a machine learning expert, it can be quite difficult. So here's an example, if you're using the Hugging Face Transformers library, that's like the most popular library for training language models. And even, Hugging Face is basically a wrapper around something like PyTorch, which itself has lots of abstractions, but Hugging Face has even more abstractions and takes care of lots of things. But even when you're using Hugging Face, there's tons of things to configure, and it can get pretty confusing even if you are familiar with machine learning. And so if you're not familiar with machine learning, then it's even more confusing. So, here's an example of actual code. That the previous slide was showing some configuration options. Here's some example of code you might have to write if you're going to be, training a model. There's lots of little details like the chat format, the tokenizer, how you split the data set, and how do you evaluate the model? Lots of little details that can get kind of annoying to deal with. And, the thing is that for most use cases, we don't need to be doing some very special customized LLM training. We really just need something that works, right? You don't need to be doing some state-of-the-art bleeding edge training methodology. There's usually just you want to start with a good model. You got your data, you want to train and have something that works well. And so, all this customization for a lot of cases is not really necessary. You can get around it. We want some level of customization, but there's kind of like in between something, there's a middle ground between no customization and this much. So HPE has this software called GenAI Studio, and it's built on some open source libraries that HPE maintains. So there's two open source, major AI open source libraries from the team that I'm on, and those are Determined and Pachyderm. So Determined is a MLOps platform for training machine learning models at scale, and Pachyderm is a data management pipeline. So GenAI Studio is built on Determined. It's also built on other open source libraries like LLM and Hugging Face and PyTorch and so on. But in terms of the actual, experiment running and resource provisioning and that kind of thing, that part is built on Determined. And so this is just a a preview of what it looks like. So it's basically a tool that makes it really easy for anyone to just start training a model. And then if you want for more customization, you can get into the Python API, but for something that's really straightforward, the GUI offers a good user experience. So now I'm going to show you a demo of it. I'm going to show you a few of the features. But actually, before I get right into that, I want to show you just to give like a bit of context and perspective. Basically, this is an example of using Hugging Face plus determined. So, these are some of the open source libraries I mentioned. And this is for fine-tuning a LLM on a text-to-SQL data set. So I'll talk more about like the text-to-SQL part later, but basically you can see there's, a bunch of commands you should run, and then there's a fine-tune file, and there's a bunch of things you have to, kind of specified, like things like how are the, how is certain data processed, which tokenizer should you use. So tokenization is like when you convert text to a format that the LLM can use. There's also this chat template. And so these models, when they're trained, you actually have to give them the data in a very specific format. So it looks like this. It's kind of this messy, hard to read format, but that's the format they take it in. And what makes it extra annoying is that each model might have its own chat format. And so it's like if you're going to write the code for this and you want to switch your models, you're going to have to change the chat format as well. Then there's issues with like how are you going to create your data sets, how are you going to split it. So here, for example, we have some code utilities for creating and splitting the data sets. And then there's also little details about like how you want the data to be created for this completion task, which is basically you want the LLM to give completion results, like complete what you've given it. And then, of course, there's how do you evaluate the model. And the issue here is like if you get any of these parts wrong, you're going to get completely incorrect results. And sometimes these things can be a bit subtle and hard to debug. So, so that's just an example of what some fine-tuning code looks like with again, these are like libraries that abstract a ton of stuff away, so they're simplifying things a lot, but it's still kind of a lot of work. And then if you want to, after you fine-tune, you often want to see how the model works or how good it is. And here's how you might do that with a simple script, right? So you would run this separately. So let me see if there's for example, yeah, so this is how you might run that script. You write Python inference, you give it the model that you're working with, and then in that inference script, we'll get back, what the expected response is and what the LLM's response is. So it's very much, and this all prints in the terminal, and you get like a few responses back. So it's not in a really nice viewable format. All right, so that's what it's like without GenAI Studio. So then if we go over to GenAI Studio, this is what it looks like, the homepage. And what you'll see first of all is that at the bottom left, there's this thing that says MLDE. So that's actually the enterprise version of Determined. And if you open that, it shows you the homepage of MLDE, which has all the experiments. It's got model registry, so it's got all the like the ML ops, the details of that. For example, like cluster usage, you can see as well. And so the point of this is that, it's built, they're tied together. So GenAI Studio is built on MLDE. So anything you do here is actually under the hood, it's using MLDE. So the first thing we might do here, you can see there's a bunch of projects, and within each project is a bunch of details. But actually, I will just create a new project so you can see the whole process. So here I'm going to do text to SQL, and I'll create. Oh, wait, let me do text to SQL too. That works. And so basically each project contains models, data sets, everything that you might do. Like this would be like a specific task or a specific use case. So here you got snapshots, models, fine tuning, data sets, and some settings that you probably don't really need to look at. So the first thing we need is a data set because we need to train a model, or at least we want to see how a model works on some data. So GenAI Studio offers a really simple way of grabbing a data set from Hugging Face. So if you're not familiar with Hugging Face, oh, let's see if I can. Um, Hugging Face hosts a whole bunch of data sets that people upload. They host it for free, and you can, on Hugging Face, you can browse the data, and then you can also see here, it's got a specific address. So this is one that was, this is a text to SQL data set that was uploaded by the Determined AI team. And you can see, for example, that it's got 3 columns, right? And each one has, so each row is basically an instruction, which is what the user wants in natural language. It's got this thing called input, which is the table definition, the SQL table definition. So this is for a database. And it's got the response, which is the query that should hopefully grab the data that would answer the user's question. Right. So in this case, it's what was the original name of the restaurant located in Orillia, Ontario, and the table definition. And this query will grab the name from the table where location equals Orillia. So this one's very simple. These can get very, very complicated. Like the tables can get, very long, and the responses, like SQL queries, can get very nested and complicated. So I mean, here you can even see a slightly more complicated one where it has to count the number of something. So GenAI Studio makes it really easy to just import this data set, and we can do that. We can just, this is just a description, it's optional. Basically, when we create this data set, what it's going to do is download it and convert it into a format that is usable by GenAI Studio. And then we'll be able to use this to test models, to see how they, what kind of responses they give, and also to fine-tune models. So under the hood, if we go to the determined page, we can see that there's a data client. And we can see it's for the text to SQL 2, which is the project we're on. And so under the hood, you can see, all the logs. And this is, very useful for debugging, for example. And basically here it's just, downloading, saving the data set, and so on. So there we have it. So there's the data set. It's got 10,000 rows. And you can see also, if you click over here, you can view the features. So this just shows the training, the data set splits. So we've got the training split, the validation, and test split. And for each split, what the columns are, what the data types are. So now if we want to see how a model performs on this data set, we can go to snapshots, and we can do a new, open a new playground. And here, the first thing you're going to want to do, there's actually 2 modes here. So there's complete and document retrieval. So I was mentioning retrieval augmented generation. So GenAI Studio supports that as well. It does require a bit more code, but that is something that you can do in GenAI Studio as well. But here we're going to focus on completion, which means, basically we want the LLM to complete what we're giving it. And we're going to use the Llama 2 7B model. So you see there's a bunch of base models here. And we're just going to choose that one since it's a small enough model for now. And here there's a bunch of configurations. So the resource pool is which set of GPUs, right? So if you go to determined, we can see in the cluster that there's different resource pools, which is like different types of GPUs. Here we've got V100, A100, And so we can select which type we want. For this playground, we don't really need A100s. We can just use a V100. It's good enough to see how the model responds. And so that under the hood, what's happening there is if we go to home and we can see the chat client. So here it's going to download a bunch of stuff. It's a fairly big model. Get that model set up so that it's ready for inference. And there's another thing here you can customize, which is the model parameters. So temperature is basically like how random the model is. So if you make it higher, it'll be more random in the way, it'll be less certain about which tokens it outputs. Max new tokens is just like how, the limit on how much it can output. Top K and top P, these are also things that control randomness. And so if you change these, the LLM will respond in different ways. Finally, there's the data set, which we want to test on. So let's see if we go back to here for a moment. So here we can see that the model is still loading. Let me just quickly check if that data set was there or not. All right, the data set was there. Okay, there, it is there. Okay, so here we select the data set and we load it. So you can see that it's got the various columns, the different columns, and it's also got the different data set splits. So you want to train on the training set ideally, and then check your accuracy on the validation set. And then at the very end, once you've picked your best model, you can see how it performs on the test set. And we can also view some more data, loading 10 more output rows, and get a sense of what the data looks like. So then if we click load, the data set is ready. And so we're still waiting for the model just because it has to, run a bunch of optimizations and so on.
So Kevin, we wait
yeah.
for the model. Somebody is asking if we have access to Llama 3.1, Phi 3.5, other models which are state LLM models.
Yeah, I'm not sure the status of that is. I don't think that'd be too hard for them to add. But yeah, for now, it looks like the defaults are Llama 2 and then also like Mistral, the previous generation of Mistral models, I think. Yeah, but I could get back to you on that. I'm not sure what the status is of adding the most recent Llama and Mistral models is.
Okay, thanks.
So the other thing is that I'll just show you really quickly is, so here I got my favorites. I got this other example, which is the news summarization. So if I go here and I open this, what you have here, this is just a little preview of what I'm going to show with the text to SQL. But here you have a summarization data set. Here we're telling the model, what we want it to do. We're giving it some examples of how we want it to respond. And then we give it the actual test case and then the expected output. And I'll explain more about these sort of templates in a bit. So then here you can see, how does the model actually respond? This generated column shows what the model, how the model responds to every input. And you can click on one to see it in more detail. All right, so let's see if this thing is done loading. All right, not yet. So let me just check one more time over here. Okay, so it is still there. So that's for this news summarization. And so, okay, so I'll just explain this now. Basically, these template strings here, they grab the column from the data set. So if you have, an article this data set has an article and summary column. So here it auto completes for you by grabbing that from the data set. And what it'll do is insert that data where you've entered it. Likewise with summary, right? So here we're saying, okay, here's the article, here's the summary that we want, that's the style we want. And then finally, okay, here's an actual article that we want the LLM to summarize, and here's the expected output. And we can see what it actually looks like if we click on preview. So this will grab one of the entries from the data set and just insert it exactly how it'll look like when you're fine tuning or when you're just testing the model. So you can see it's got article, it inserted the article where we want it. And likewise with the summary, this is the desired summary. And so let's see if there's, all right, so this one is ready. So this is going back to the text to SQL model. And what we want to do is basically get it to convert the natural language into a SQL query, right? So we can say you are a coding assistant that who is good at writing SQL queries, and you respond with only the SQL query and don't explain your response, something like that. Hopefully that works. So that's the instruction that's going to be given. That's like the system prompt, which is you're telling the LLM how you want it to respond generally. And then you can give it an example. So here we want to say, here is an example. You can say SQL, we can say table. And again, we're using that template syntax. So we want the input. The input contains the table definition, the request or the query will be in the instruction, and let me see, I'll call request and call this one as SQL query, and this one will be the response. And then, so that's the example that we want. And then we want something basically the exact same format for the test case. So here we're going to say, we're going to have the exact same stuff, but we're going to leave out the correct response and instead put that in the expected output. And if we want to just make sure this actually makes sense, right? I wasn't totally sure whether, I couldn't remember which one these correspond to. We can, again, do the preview. Here's an example, table, create table. So that looks correct. The request is what was the original name of the restaurant, and then the SQL query. So it looks like I've got the column names correct. And then again, table, request, SQL query, but this time the output is in the expected output. So then we can do, to see how the model performs without fine tuning, we could click on generate. And this will just get a few responses from the data set. It'll show up here, and we'll be able to see, how good it is so far without fine tuning.
Kevin,
Yep.
while this is happening, somebody is asking if we need a GPU for running AI Studio.
That's a good question. I mean, oh man, I can't remember if it's a strict requirement, but you're going to have a pretty hard time running anything, any one of these LLMs. I mean, they just take a lot of compute, and even like you can see here, it takes a while to generate some output, and we're using V100, A100, like we're using these very high-end GPUs. So
Oh yes.
yeah, so it's like you can run determined on CPU, but it's just, yeah, so I'm not sure if GenAI Studio itself can run on CPU, but it seems like it'd be difficult to get anything done.
And
Yeah, so
we have another question on how can we get access to GenAI Studio? Is it just a download from
yeah, no, so So determined is free and open source, and then there's the enterprise version, which is called MLDE. GenAI Studio is only an enterprise product. I think the best thing would be to send me an email about that, which I can put in the chat, or maybe you can, or I'll put that in later. And then I can direct you guys if you're interested. Anyone who's interested, I can direct to the right people. There was a link that I was going to put in the slides, and then I realized it was a bit out of date. So yeah, so in terms of getting access, yeah, probably just sending me an email is probably the best way at the moment.
Okay.
So if we look at chat client, see average throughput. All right, it's taking a bit longer than usual. Let me just see if I can show you what it looks like when it is done. Where was it? It was this one here. So yeah, sometimes it can take a while because there's a lot of entries in the data set. And it is a big model. So here, if I go to snapshot 1, it'll already have some. So basically, this is what it will look like once it's done generating those outputs. So, all right, I'm going to toggle this full width. So here you can see the generated column. This is what we expect. These are the columns I showed you before. These are just the original dataset columns. So these ones are the more interesting ones. Here's what the models generated. Here is what we expect. It actually got this first one correct. But the second one, we can see it did not get correct. It's not really even close. Actually, a bunch of these start getting pretty inaccurate. So there's a lot of room for improvement. The other interesting thing is that it formats the chat correctly. So this is something I mentioned when I was showing you the sort of the raw code over here. So it takes care of all this like formatting. This is actually what is input to the LLM. You've got like the starting token, you've got this instruction token, and then you've got this, which indicates that it's the start of the system prompt. And then you have, the end token as well. So it doesn't seem like a big deal, but it can be a bit of a headache, especially when you start switching around models. So just as an example, if I go to snapshot 2, so you can see here, snapshot 1, I've got this, I'm using Llama 2. Snapshot 2, I'm using a different model. And if we go in there, so I did the exact same thing. I got it to generate some responses. Here you can see that it also has, actually, yeah, this one does pretty badly. Like this one says, where is it? What it generated was, I'm sorry, but I need more context. So this one seemed to do worse than the Llama model. But the chat format specifically, you can see that it's got a totally different format. It's not even similar, and uses this im start, im end, and so on. So no, it's actually im start system, and then you got im start user, im start assistant here. So again, one of those like little details that's really annoying to take care of, and GenAI Studio does that for us. So if we go back to here, we can see that it did generate a bunch of responses. And again, I already basically showed you this in the other playground, which is that it's getting a bunch of them incorrect, and there is a lot of room for improvement. So if we want to fine tune this now, what we can do is first, what I'm going to do is save snapshot. So I'm going to call this snapshot SQL, text to SQL, snapshot 1, and saved. Okay, so then if we go back to snapshots, we can see it's listed here. We can see which data set it uses, which model it uses, and but now we actually want to use it, right? So if we go to models, we see there's no models that we fine-tune. Fine-tuning, likewise, we don't see anything. So what we want to do is click on fine-tune model. And first thing, we got to give it a name. So I'll just call it text to SQL, or I'll call it Llama SQL Finetune. And the next step is optional, but it's really convenient, right? So if we just go next, we have to kind of select which model we want to use and all that. But if we pick a snapshot, which we were just looking at and which we just saved, it'll fill in a bunch of stuff for us. So first of all, it tells us, we can see at a glance, okay, it's using that text-to-SQL data set and it's using the Llama model. And if we go to the next step, we can see, okay, it's already filled in. It already knows I want to use a Llama model. Here we can pick, again, the resource pool. We're going to use the A100 because we're training and it's a bit more demanding than just requesting responses. And also you can see that it has a recommended config. So we can use A100 with a recommended config, or we can do with custom config. I'm going to go with the recommended. It's already got a bunch of stuff filled in. It knows that I'm probably going to need 4 GPUs. And then a whole bunch of stuff here already filled in, like the learning rate, the context window, right? So how many tokens it's looking at a time, the batch size, how many steps are we going to train for? How often are we going to check the accuracy? How often are we going to log data? And how often we're going to save checkpoints. So we're only going to save the very final checkpoint. And then these options down here are basically optimizations to make the model more likely to fit into the number of GPUs you have. Right, so floating point 16 just means using a more compact data format. Deep speed partitions the model and optimizer onto different, it spreads the model and optimizer across multiple GPUs. And gradient checkpointing is basically just another optimization for decreasing the amount of memory that you need. So I'm just going to leave all of that as is. Here we get to see the data set again. And the nice thing here is you can change how much data you want to use for training, validation, or testing. So got this nice slider here. You can, change the proportions. I'm just going to leave it as 80, 10, 10. But if you want something different, you can modify it there. Finally, there's the prompt that we want to use. And this is, again, this is the advantage of using that snapshot. It's already filled in. So we're using the exact same thing that we tried out in the playground. And again, you can preview it just to make sure it looks correct. And that's basically the final thing. So we can launch fine-tuning. Give that a few moments. All right, so then if we go over to the fine-tuning tab, we can see that there's a job in progress. And you see it's running. And if you click on this, the name of the fine-tuning job, it actually opens determined and it brings you right to the fine-tuning, the experiment. So this is where the model is actually being trained. Once it gets going, you'll be able to see the metrics. So you'll be able to see accuracy and the training loss. You can also see all the hyperparameters that are used under the hood. So there's clearly like a ton of things that it's that's been configured. We got to see just a tiny portion of it in that configuration menu, but there's actually many more things that are going on under the hood. And of course, you can see the logs to see what kind of progress it's making, what stage it's at.
Kevin, the mortals want to know how do you measure the performance of the fine-tuned model? Do you get a dashboard? Do you get an evaluation, or what's the
Yeah, so the best, there's 2 ways. Basically, for the dashboard type of thing, what you are going to want to use is the determined UI. So this will, once it actually starts training, you'll have things like the accuracy as it's training, the loss. And then if you want more of a qualitative evaluation, that's where you'll go back to GenAI Studio and you can see how the model performs. So that's what I'll do in a moment. But yeah, so in terms of like actual numbers, you would use the determined UI. And like the actual metrics would basically be like how closely it's matching the the correct response. Oops. So the at this moment, let's see what it's doing. I believe the training. Okay, yeah. So once you see it's got that like blue bar, you can see that it is going, so it's got 100 steps. It's done 4 steps so far. So that'll take a bit of time. So in the meantime, what I will do is show you, let me just go back to home. So I'll show you what it looks like basically when it is done. What you can do here, let's see what I can do. If I open this one here. So what you can see is you've got your list of models, and then you've got this is a previous model that I fine-tuned. So I'm going to use the same V100 and load that. And so while that's loading, we can see here in the actual training run that I'm doing now, you can see that it's going through it's going through the training samples, and then it has a validation set. So once it has a validation set, that's when you start to get these metrics. So here we've got, the first metric, it's at the 25th iteration. You've got accuracy of 90. You've got the loss. You've got some other sort of diagnostics that you can look at as well. And let's just see if this one over here. Yeah, so this is the Llama Fine-Tune I'm trying to load at the moment. Yeah, are there any other questions right now, just while we wait
Yeah,
for
there's somebody's asking why you creating a new table for each prompt?
Why creating a new, sorry, what was it again? Creating a new
Creating a new
template?
table for each prompt seems unwieldy. Unwieldy. Can you
Yeah.
explain why you do this?
So the way I'm not totally clear. I guess so basically what you have is you've got the system prompt that's basically explaining how, the model should respond generally. You've got an example. Do you mean, I guess
Maybe Sean, you can ask the question in a different way, and we'll ask the question again. We have another question on do we support any kind of RAG or graph RAG?
yeah, so there is a RAG component. Let's see if I can. It's a bit more complicated, so I'm not going to go into it in this session, but there's basically a RAG API that you can write. I don't think there's from what I know, I don't think there's support for graph RAG specifically, but if you're just talking about like a standard vector DB, that kind of thing, you can write out code in like a Jupyter notebook. There's like a library, so it's called lore. So lore Python SDK is basically like the API for the Python API for GenAI Studio. So for example, it might look something like this. This is just lore in general. So you can do everything that you see on the front end, right? In the GUI, you can actually control in the Python SDK. So you can get into, really granular sort of customization. And as part of that, you can also set up a RAG pipeline, which you can then interact with in the front end. But it is a bit, at the moment, it does require a bit of coding to get that pipeline set up. So, but there are some, there's some examples in the documentation of how that might work. So for example, creating the embedding model, setting up your vector DB, in this case, Chroma DB, inserting a CSV file into the database, and then you create this RAG pipeline from which you can then go to the front end and then now retrieve documents, test out the RAG pipeline.
Thanks. Sean has explained the question again. So he says, you seem to be creating a table, inserting data, and then doing a select on it. Is there a way to avoid creating all those tables? Or is it needed for your training purpose? Do you delete them all later?
Oh, I see. Yeah. So this is all just text. So there's no actual queries being executed. These are just like, uh, yeah, it's just text only. So we don't even have a database connected to this training data. All the LLM is getting is some text, and then it's supposed to respond with the correct text. And we have this. How do we know that it's correct? Well, it's been curated, right? Someone put together this data set. They put together all these table definitions, the instructions, and the responses. So it doesn't.
Expected data is also part of the data set, right? Because people are asking this also. Is the expected data in the data set or?
Yes, yeah. So the expected is like the correct answer, basically, right? The correct response query, that's part of the data set. So yeah, otherwise we wouldn't know how to tell the LLM the correct answer. I can see maybe some people might be thinking like you could do it without the correct answer by actually executing this in a SQL, environment and like checking if the retrieved data is what you want. And that would be very cool, but it would be a lot more complicated. And so this approach that where people have, manually put together a data set that consists just of text and where you don't actually have to execute any SQL queries, it's a lot easier to manage. But that other approach, yeah, if you could do it in like a SQL environment and actually test things, that could be a very interesting. Though, I mean, yeah, it'd be pretty complicated, I would think.
Thanks.
All right, so this one here, actually, just before I go to that, let me check really quickly if this thing is actually making progress. Okay, it is. So what I wanted to show was this fine tuning. So this is what it looks like once the fine tuning is complete. Again, this is the validation loss. You can add other things like eval accuracy if you want. So this is the kind of, dashboard that you can look at if you're looking for, quantitative stuff. You can see the different, these are the different points at which it evaluated the model. You can see that it's got a checkpoint. We only have one checkpoint just because we don't want to slow things down too much. It's got an ID. So there's a lot of things you can do and determine once you have, these fine-tuned models. You can add them to a model registry and so on. So on the front end, let's see if I go to, where was it? If I go to home, text to SQL 2, and if I go to the snapshot, which will hopefully load, all right, here, text to SQL snapshot. Basically, now that model is available for us to try out. I'm going to leave that though, because hopefully this other one, okay, yes, this one did finish loading. So this is a previously fine-tuned model on the exact same task. It just had a slightly different prompt. And then what we can do is see how it responds, right? So what we know is that the base model that wasn't fine-tuned was having trouble with a bunch of these things. If we generate some responses with the fine-tuned model, hopefully it'll get more of these correct. So here, okay, on the training set, this is expected, right? Because it's already seen this data, but at least that's like the bare minimum we want. We want it to at least do well in the training set. So you can see, all right, looks like these are all basically identical. This one I think I got this one wrong here, but it's a better accuracy rate than what we had before. And then likewise, if we look at the test set, it's doing much better than it was doing before. And so the test set, of course, this is the data that it hasn't seen. That's the most important, right? We want it to do well on unseen examples that, are going to be thrown at it in the wild. So that basically covers the model, testing, inference, fine tuning, covers that whole pipeline. If there's anything else, let me just think if there's any other major features. I briefly covered the Python SDK. There is, you can upload your own data set, which I don't have an example right now, but if you go to home, let's see if I go to text to SQL, go to data sets. When you do new data set, it doesn't have to come from, Hugging Face necessarily. That's just like the most common way people interact with data sets. But you can also upload a data set, like basically if it's in a CSV format and you got columns and data in each of those columns, you can do that as well. So yeah, that basically covers the main sort of the features of GenAI Studio. If you have questions, let me see if I can get to the chat. I'm going to stop sharing for a moment. And
Aidan
I'll
has
just
already shared your email, so in the chat. So
oh, okay, great. Yeah.
get in touch with you. I think we answered most of the questions. I brought up the end of session poll, so if people can give us a quick feedback here, that would be helpful for the future. It's a very quick 3-question type of thing, so please answer the poll. And right now, I think in the chat you answered everything. There was a question about dashboard, but I think you showed some of the dashboard we have for evaluating the accuracy and
Yeah, in terms of specific accuracy metrics, you can customize that more with the SDK, so that the Python API. But if from the front end, it's kind of just set for you to accuracy.
any remaining questions or anything you want to do as a closing, Kevin?
Yeah, just let us know. Yeah, let me know by email if you have more questions. We have a lot of engineers who can answer more technical questions and how to set things up and that kind of thing.
Okay. All right, everyone, I can leave the poll a few more minutes before closing the call. Thank you for answering the questions in front of you. That should be quick and give us a good feedback on the session and upcoming sessions. So thanks everyone for joining and have a good rest of your day. Thank you, Kevin.
All right, thanks everyone.